Okay, we are going to talk about rational function. Rational function, like for example, the simple one, y is equal 1 over x. See, this one was different from linear function that we had y is equal to x plus minus 1, for example. You give value to x, you find, or to find y, or one time x is equal to 0, you find y, or if the y is equal to 0, you find the x. You know, and then you find 2 points. Let's see, just do example. If x is equal to 0, this is going to be 0 and this is going to be minus 1. If y is equal to 0 to x minus 1 is equal to 0, x is equal 1 over 2. So we just graph this x0 minus 1 point here, and when y is 0, x is equal 1 over 2 this here. And then you connect these two, you draw the one of the way to draw that, or even give value to x and find y. So but this is you know, it's a little bit different. See, never x is going to be 0. X can't be 0 because 1 divided by 0 is undefined, infinity. So anything x, it can be anything except 0. So let's draw this. See, we are talking about vertical asymptote and horizontal asymptote pretty soon, but just for now, let's draw this graph. X, y is equal to 1 over x. You give value to x, like minus 2, for example, we get minus 2. Okay, what is going to be? Y is equal 1 over minus 2 is it going to be minus 1 over 2. Minus 1 over 2. If we give then 1, what is going to be 1? Y is equal to 1 over 1 is equal to 1. So one point is minus 2 minus 1 over 2, and the other point x is 1, y is 1. Say and see, we give some value to x, and we know that this is going to be look like this. But let's see. You give some value this way, like suppose let's write it here in a better form. Use another this one here. Okay, now I had some ink in it already. So we give value to x and find y. See, I said like we give value some to x here. Start from minus 2. The answer was minus 1 over 2, and then minus 1 is going to be minus 1 is going to be 1 over 1 over minus 1. Y is equal to minus 1. And this one we put going to be minus 2. see, what's that? 1 over minus 2. Or minus 1 over 2. So we find this one, and then we find some other points. We find here, let's see, so for what we said minus 3, y is equal 1 over minus 3 is equal minus 1 over 3. So how about, let's see, locate this point, minus 2, minus 1 over 2. This is minus 2 here, and it's going to be a point here. Minus 1 over 2 here. And then minus 1 is going to be minus 1. The point here. And minus 3 is going to be minus, it's getting smaller and smaller. And something, we say that this is, we know it's going to be like this. Whenever x is, minus x increases, minus x, it's getting less and less, minus 1, minus 2, minus 3, you know, we find that, like it said, minus 10 is equal y is equal 1 over minus 10 is equal minus 0.1. So if this is minus 10 here, for example, it's going to be, you know, if there is minus 10 here, this is going to be so close here. Actually, the point is minus 10 minus 0.1 or 1 over 10. So it's getting smaller, and it's going to, if you give a big number, this is going to be much smaller, so it's going to get to 0. So this is going to, and finally it get to, at the infinity it gets to 0, but it's going to be less and less every time, you know. Let's find another point here, minus 1 over 2. Minus 1 over 2 means here. You want to find the rest of it to see what the graph look like. So y is equal to 1 over minus 1 over 2. See what is going to be? It's just reversing these two is minus 2 over 1 is equal to minus 2. So minus 1 over 2 is going to be here. The point is minus 1 over 2, this is minus 2. So if we get another point just less than minus 1 over 2, you know, this is actually minus 0.5. Let's say minus 1 over 8. Okay, this is 1 over 8. 1 over 2 was half of it, 1 over 8 is 1/8 of that. So y is going to be 1 over minus 1 over 8 is equal to minus 8. So actually 6, 7, 6, minus 6, minus 7, minus 8. So it's going to be, and this one, 1 over 8 is smaller. It's going to be something like this. So it's going to come like this. So how about the other point? Let's see if we have a positive x-axis. So in positive x-axis, we can write what is 1, 2, 3, 4, y is equal to 1 over 1 is equal to 1, y is equal to 1 over 2 is going to be 1 over 2, y is equal to 1 over 3, and 1 over 4. or 1 over 4, you say, you know, it's going to be so a small number, and so what it means here, if x is 1, this is x is 1. If x is 1, y is 1. Okay, the point here is this one, the 1 point. And then x is going to be 2. X is going to be 2, it is going to be half of this. And then x is 3, 1/3 of this. It's going to, and you know, we know that it's going to go this way. How about at the other side of the, this is 1 point, plus 1. This is 1 over 2. How about, say, x 1 over 2 is less than this number. See, we want to see what the graphs look like at the between 0 and plus 1. It's 1 over 2. Y is equal to 1 over 1, 2 is equal to 2. So at 1 over 2, it's going to be this point here. And 1 over 5y is equal 1 over 5 is equal to 5. See, it's getting so small, and 20% of this is going to be here. So actually it's going to look like this. You know, it's to plus infinity, and this one is plus infinity, and this is minus infinity, and this is minus infinity. See, this look like this. It's really hard. This sometimes it's hard to graph this. But the thing is, if you give, what about if you give 0? If you give x 0, y is equal to 1 over 0 is going to be what? Infinity. So what it means, if x is 0, then y is going to be infinity. So we can't make the denominator 0. If the denominator is 0, one number divided by 0 is going to be infinity. So we got some idea what this look like. Let's talk about the domain a little bit here. We will gotta get into that in more detail. See, the domain is the value of x can get in x-axis. The domain related to x-axis. See, from minus infinity to 1, except 1. No, 1 is not included. So we say that the value of x can get, we said we can give minus 100,000, you know, whatever, minus a million, you know, we can get this value for y. So the lowest, the x domain means all the value of the this function that value of x that this function can get. So from infinity we can get lowest number is minus infinity. Minus infinity up to 1. Up to 1 is not included 1. And then again start minus infinity to 0. I'm sorry, 0, because this is up to 0. Not 0 is not you know, if x is 0 it's going to be infinity. So from minus infinity to 0, 0 not included. We use parentheses here, and the union of, and then start from here to there, except 0 go to plus infinity. This is the domain, you know, all the x value that it can get. So let's let's solve another example. See, x is going to be x minus 1. What does it look like? Okay. This is actually the vertical asymptote and horizontal asymptote. You know, if you have an asymptote here and this is 2 and your graph look like this, it means that if you put 2 in there, it's going to get to infinity, so 2 is not included. What we do, if we find that the vertical asymptote is equal to, if the denominator is going to get set it to 0 in order to find the x is equal to 1. The vertical asymptote. Now let's okay. So let's see what is there's going to be a vertical asymptote at x is equal to 1. Mean here x is equal to 1. We got vertical asymptote. Means if in this equation, if we put 1 here, x is equal to 1, x is equal to 1, it's going to be 1 over 1 minus 1 is going to be 0, it's going to be infinity. Means you can't, this, the domain of this function is not going to be not included 1. Doesn't include 1. Okay? Means any other number except 1 is, you know, it can be, you can substitute in there and you can find the value of y. So vertical asymptote is x is equal to 1. And horizontal asymptote, then we talk in more detail that we look at the degree of the numerator and the degree of the highest degree of numerator and the highest degree of the denominator. The degree of the numerator is going to be, this is actually the degree here. It can be, say, x 1 times x to the power of 0, which is 1. Means the degree of the numerator is 0 and the degree of denominator is 1. So any number to the power of 0 is going to be 1. So when you have something like this, the numerator is less than the degree of this one, numerator is less than the denominator, horizontal asymptote is going to be equal to 0. Means here, actually, you know, y is 0 here. You know, remember in linear equation that we say y is equal to mx plus c. In linear equation, if we put if x is 0 and this is going to be c, we find the value. If we put the value of x is x equal to 0, means you want to find the value for y. When x is 0, 5. So if you see if it goes to 2, then y2, y is equal to 2. This is also equation, a linear equation. This is also a linear equation, but it doesn't have this item. It doesn't have this item. Or y is equal to minus 3. You know, here is 1, 2, 3 minus 3 is going to be a line. Y is equal to minus 3 is going to be a line parallel to x-axis, and at -3, it is -3. So these are linear equation, or the same thing for. Okay, let's finish this one. So we have a horizontal axis is equal to 1, vertical is equal, horizontal is 0, y is equal to 0, means lies on this axis, x-axis, and x is equal to 1. Here is the vertical asymptote. So here it's going to be look like this. This is 1. It's going to be look like this, but you know it's not that sharp. So this is not going to get to this. Okay, this is at the infinity it's going to get to when it get to x is equal to 1, then you know it's we can say we say it's not defined, or is infinity. Okay, let's draw this. With what we do, we say at this here we're gonna. It's really take a lot of time. This rational function, that you have to find some value for x and y, which is 1 over x minus 1. So you give 2, you give x is equal to y is equal to 1, 2 over minus 1 is equal to 1 over 1 is going at 2 is going to be 1 point here. At 3, okay, it's going to be y 3 minus 1 is equal to 1 over 2. 3 at 3 is going to be half of this is going to be 1, and at 4, and also it's going to get smaller and smaller and smaller, it's like this, but it's not going to be 0. It's not going to get, it's going to get to infinity. How about some point here? This is between, this is plus 1 and this is plus 2, something between. We say that 3 over 2, 1.5, 1.5. We are going to find out the point. Y is equal to 1 over 3 over 2 minus 1. We know that how we find this, it's going to be 3 over 2 minus 3 over 3 is equals, 2 over 2 and minus plus 1 over 2. It's okay, and then this is going to be 2. So at x, so it's 1.5 here. This is going to be 2. It's going to be here, and also the same thing for it's going to get so smaller and larger and larger. And this time it's going to be smaller and smaller. So it's going to be, you give value. You give value to x, and also you can give a value between 1 and 2 to find these points that it's getting so close to, every time you go up, it's getting so close to vertical asymptote. So let's find a point here at this part of it is 1, okay, x 1, y is equal to 1 over x minus 1, and if x is minus 1 over 2, y is equal to 1 over 2 minus 1 over 2 minus 1. It's minus 3 over 2. It's going to be minus 2 over 3, right? Because we make it the same denominator, the common denominator is going to be this one, and then 2 minus 1 minus 2 is going to be minus 3 over 2, and inverted is going to be 2. So at minus 1 over 2 is going to be x is minus 1 minus 2 over 3. 2 over 3 is 0.6. It's going to be something like that here. And then we say x is equal to let's give a number here. X is equal plus 1 over 2. Y is equal 1 over 2 plus 1 over 2 minus 1. So it's going to be 1 over 2 minus 2 over 2 is equal to minus 1 over 2. And then in inverted is going to be minus 2. See, if you go minus 1 plus 1 over 2 plus 1 over 2 is going to be minus 2 here. It's going to be point here. And also, we know that this is going to go this way, going to go this way. So that is the how to graph this rational function. That they are more complicated. Like suppose that actually if you give you one more 1x minus 2. What's going to be, this one is going to shift this one here, x1, 2, this is going to be vertical asymptote. Vertical asymptote is equal to 2, so this is going to go this way. And if this one increases 1 over x minus 3, that one is going to shift like for example x minus 4. X is equal to 4 is going to be the vertical asymptote. It's going to be this, and then if we clear this, this is going to be like something like this. See, every time you add the number here, it's going to shift this way. So these are the things. But we just talk about the simple one. Then next we are going to talk about that. We have like x plus 1 divided by minus 1. What is going to be the vertical and horizontal asymptote? We'll talk about this later.